So in this video, we're going to talk about a very popular application of trigonometry, which is angles of elevation and depression. So what an angle of elevation is an angle between the horizontal line of sight and the line of sight up to an object. So if you look at this person right here, if you imagine they're looking up at an object, okay? So up here you have like a bird, plane, whatever's up there. So they're looking up at this object, right? You can see with this dotted line right here showing their line of sight. And then what happens is it forms an angle with the horizontal, right? So this purple line that I've drawn in here, that represents the horizontal. So there's angle right here, okay? This angle theta is what's called an angle of elevation, okay? So it's the angle for somebody looking up at an object. We also have what are called angles of depression. So that could be a person looking down at an object, okay? So what happens here, you can see once again the dotted line represents a line of sight. It's usually like a person on a building or a plane looking down at something, okay? And then down here, they're looking at another object, like another person, a park, a flag, something. Well, what happens is there's an angle that's formed once again with the horizontal. And if we call this angle, let's call it alpha. So this alpha is going to be an angle of depression. Okay, so it's the angle when you're looking down at an object. So what we can do now is we can use this to solve some problems. So it says at a point 60 feet from a tree, the angle of elevation to the top of the tree is 40 degrees. Find the height of the tree to the nearest tenth of a foot. So let's go ahead. It's always very useful in these problems to sketch a picture, okay? So there's a tree, so I'm going to draw in a tree. And then it says the angle of elevation from a point 60 feet away, right? So this point is going to be like, you know, if we imagine this is the ground, so 60 feet away, here's our point, and this distance is 60 feet. So the angle of elevation up to the top, right? So if we draw in our angle of elevation, because remember it's going to go up, that's going to be 40 degrees. Okay, so what this will form is it'll form a right triangle, okay, because the tree is going vertically up, and so you can see this is going to be 90 degrees. So now we can use our trig ratios to figure out what it's asking us for. So here it's asking us for the height of the tree. So if I call the height of the tree y, we can set up a trig ratio, right? Because we have an angle, we have y, which is the opposite, and we have 60, which is the adjacent. So that means tangent of 40 is equal to y over 60. Right? And so if I was going to solve this, I could solve by multiplying both sides by 60. So I have 60 tangent 40 is equal to y. Okay? And so now you just basically type this in your calculator as long as it's in degree mode, right? Make sure you all are putting it in the correct mode. And then it says nearest tenth of a foot. So we're just going to round that to 50.3 feet equals y. Okay? So now let's try another one. It says from the top of a 100-foot lighthouse, the angle of depression of a boat is 15 degrees. How far is the boat from the bottom of the lighthouse to the nearest foot? Okay, so let's sketch our picture. So I'm going to sketch a lighthouse. I don't know, let's pretend this is a lighthouse. So here's my lighthouse. And we know that it's 100 feet tall. Okay, so it's 100 feet tall, and then it says the angle of depression to a boat. And angle of depressions are a little bit trickier to draw, okay? Because what happens is like it's the angle down like this. Okay, so like we're going down to a boat. Okay, so there's my boat. And then the angle of depression is actually going to be the angle with the horizontal. Okay, so it's going to be this angle right here. And this can be a little bit tricky when you're first learning these problems because a lot of people will want to call it this angle. But it's not, because that's not the angle of depression. Remember, the angle of depression or elevation is always formed with the horizontal. So that's why this angle right here is the angle of depression. So this angle is going to be 15 degrees. And what's happening is this lighthouse is going to form a 90-degree angle with, let's just say this is the water, okay? And so what we need to do now is figure out what this angle is, because this angle is what we need to solve for the missing value in this triangle, right? Because the missing value is like, what is this distance right here? Well, what happens is the way these are set up, this 15 degrees and this missing angle are actually going to add up to 90 degrees. Okay, so that angle, so like the angle we need plus 15 degrees is going to equal 90 degrees. So if we just go ahead and do a little bit of algebra, we can find that that angle is equal to 75 degrees. Okay, so now if we think about the trig ratio we can use, we have this angle, we have the opposite, and we have the adjacent. Okay, so tangent of 75 equals opposite, which is x, over adjacent, which is 100. So now we have 100 tangent 75 equals x. And if we just go ahead and do this on the calculator, we have 373.2 feet, and that's equal to x. Okay? All right, so now you can go ahead and pause the video and try doing this example on your own. Okay, so here we have an airplane 5,000 feet above the ground. The angle of depression is 5 degrees. How far away is the airport? Okay, so if we look at this problem, you can see we have 5,000 feet up in the air, right? That's our vertical direction. Be careful with those angles of depression because remember they're formed with a horizontal, okay? So it's going to be this 5-degree angle right here, which means this is going to be 85 degrees. So the airport distance, I called it x, so that means we can relate these two values using tangent. So we have tangent of 85 equals opposite, which is x over 5,000. So if we do 5,000 tangent 85, we get 57,150 feet, which is how far away the airport is.